Hello students, myself Bhagyashree Shenkar from MIT ADT University. So today we'll see heap sort algorithm, its theory and implementation part. So before going towards the implementation parts, let's have a look about what is heap, okay? And then we will see what is max heap. After max heap, we will see what is mean heap, and after this mean heap, max heap, and heap, we will see what how we can represent heap by using array. Okay, we can say representation of heap using array. Then we will see how we can construct heap, that is construction of heap. And after that we will see heap sort. We can sort particular numbers by using this heap property. So let's have a look of regarding heap sort. So heap is a binary tree and it having two special properties. First one, it must be the almost complete binary tree. It must be a almost complete binary tree. What is almost complete binary tree? All the labels should be filled from left to right. Okay, and you need to and uh, it is binary tree. It's at most two children it's having. For example, suppose here is the 10, okay, and here is the 5, and here is suppose 15. Here is 6, here is 4, and here is suppose 7. So this is almost complete binary tree. Why? Because each and every levels is completely filled from each and every level is filled from left to right. That's why it is called as a almost complete binary tree. Now this is regarding the first property. Now second property is it can be a main heap or a max heap. Means what? In the max heap, the parent value is greater than the children's value. Okay, whatever the parents nodes are there in the tree, that value is greater than its children's value. That is the property of a max heap. And then mean heap means the parent value is less than its children value. So that is the property of a mean heap. Okay, so these are the two types of heap we can say. So let's see one example of mean heap and max heap. Now suppose here is one tree, here is 4, here is 12, then 4, 4, then suppose here is 5, 10, then here is 13. Then you can observe thus that this is mean heap. Why it is mean heap? We need to check first of all it is almost complete binary tree or not. All levels are filled from left to right. So we can say this is almost complete binary tree. Now check this property. What is a mean heap property? Parent value is less than its child value. So parent value is 1. If you are considering this one, parent value is 1, child value is 4, 12. Means parent value is less. Okay, so moving towards a left subtree of 1. So if you are considering this one, parent value is less than its children's. If you are considering the right subtree, parent value is less than its children. That's why we can say this is mean heap. Now let's take the example of a max heap. Suppose here is 9, okay, then 7, 6, 4, 2, and here is 3. So check whether it is a max heap or not. So first of all we need to check whether it is almost complete binary tree or not. Yes, it is almost complete binary tree because each node having at most two childrens and levels are filled from left to right. Okay, so this is the almost complete binary tree. Next thing we need to check regarding the max heap properties. Max heap property is parent value is greater than its children's value. Now check this one. This subtree, parent value is 9 and children value is 7 6. So parent value is greater than its children's. If you are considering here, parent value is greater than its children. If you are considering the right subtree, parent value is greater than its children. That's why we can say this is the mean heap. Sorry, max heap. Okay. So this is regarding heap, max heap and mean heap. Now, how we can represent this mean heap or a max heap? By using array, because this you require for the implementation of a heap sort. Let's take the same example of mean and max heap. If you want to represent this mean heap you by using array, how many elements are there? 1 2 3 4 5 6 elements. So zeroth element we will keep blank, and first, second, third, fourth, fifth. So we will place values of this particular tree from left to right at each and every level. Means we will go level by level from left to right. So first level, first node, one node is there. Second level, 4, then 12. We need to go from left to right. Then here next level, 5, 10, and last one is the 13. So in this way we can store this mean heap into the array. Same way if we are considering the max heap, okay, first zeroth index will be blank, then first, second, third, fourth, fifth and sixth. So we will go level by level, left to right. So first level 9 is there, second level 7 6 from left to right, okay, and last level 4 2 3 from left to right. So in this way we can represent the max heap, mean heap by using array. Means we can store that value of a man and mean and max heap by using array. So this is regarding representation of heap using array. Now we'll see how we can construct the heap. For construction of a heap, there are two ways. First one is insert key one by one. Second method is heapify method. So in heapify method, we this insert key one by one. Maybe this method you have seen at the time of theory lectures. So I'll move towards the heapify method. So this method we are using for creation of a heap in the heap sort. That's why I'll explain this heapify method. So in heapify method, okay, if you want to find out the max heap or a mean heap by using heapify method, how we can find out, that we will see. So let's take one example. Suppose here is 77, here is 15, here is 91, then 21, then 6, then here 46. This is the tree. We need to create a max heap for this particular tree. Okay, so we need to apply the heapify method. So how we can do it? So whatever the leaf node are there, that we need to reject. We will not do processing for the leaf node. We will process only the non-leaf node. Okay, that is the major advantage of a heapify method. In insert key one by one, all keys we need to process, but in heapify method we will process only the non-leaf nodes. Okay, if you want to apply heapify method, you need to start processing from rightmost node, okay, and the second last level. So this is the second last level, rightmost node we will consider, and we will compare this with its children's. So after comparing this with its children's, okay, we 91 we need to compare with the 46. So parent value is greater than its children value, so no need to swap it. Okay, so next element is 15. So check parent value is greater than its children or not. In this case, parent value is greater than parent value is less than its children's. So we need to swap. So which element we need to swap? Which one is the greater, either right or left? So right one is the left one is the greater. So we need to swap it. So after swapping, the tree will be like this: 77, 21, 15, and here is the 6, here is 91, here is 46. So tree will be like this. Okay. Now check whether it is a max heap or not. It is not a max heap. We need to process this one also. So this we need to process. So we need to check whether this tree, subtree is a max heap or not. We need to compare this. Now 91 is here, which is greater than 77. So in that case, we need to swap it. So we will swap it. Okay. So 91 will go up. Okay. And 77 will go down. So here is the 21 as it is, 15, 6 as it is, and here is the 46 as it is. Now check whether it is a max heap or not. If we are considering this subtree, right subtree, we can say this is the max heap. Okay, maximum value, parent की value max है. Okay, then if you are considering the left subtree, parent value is greater than its children, so it is a max heap. Now consider the this tree. Okay, 91, which is greater than this 21 and 77. So this we can say as a max heap. So in this way we can create a max heap by using heapify method, which you require for a heap sort. Now in the heap sort, what are the steps? So this is the construction of heap. Now we will move towards the heap sort. So what are the steps for heap sort? Okay, we need to process all elements up to all are sorted. Up to all elements are sorted, we need to process all the elements. So what process we need to do? Step 1, we need to perform heapify method and find out heap max heap. Okay, after finding out the max heap, next step is we need to swap. What we need to swap? We need to swap last root element and last element, and then reduce size of array by 1. Okay, so we need to swap root and last element, and after that we need to reduce the size of 1. These two steps we need to do up to all elements are sorted. Okay, this is the heapify method you require during the heap sort. Okay, we have seen that heapify method right now. So we are swapping root and with the last element, because actually we are performing deletion method. Actually what we are performing, deletion of root. Okay, that method we are performing. Means in the first step we will find out the max heap, and whatever the maximum element is there, that we will delete. Okay, so how we can perform that? We will delete the root element with its last element. That's why we will swap root with the last, and every time we will reduce size of an array by 1. So in this way we can perform the heap sort. Let's see the example of this heap sort. So in heap sort, we will take the same example that we have seen for the heapify method. Suppose elements are given like this: 77, then 15, then 91, then 21, 6, 46. So these are the elements, 6 elements, and you need to sort this particular element by using heap sort. So what are the steps for heap sort? As I discussed previously, first we need to apply heapify method and find out the max heap. Then second method, we need to swap. What we need to swap? Root element with last element, and then reduce size of an array. When actually we are performing deletion operation of a root. Okay, so let's see this example, so you will get the clear idea regarding same. Now these are the elements, so how we can store that element in the array? In the same way which is given. Okay, so this is our array, we can see. So how your tree will be look like? 77, here is 15, left to right we need to go. So after that 91, the next level 21, next level 6, and then 15, 15, 91, 21, 6. Okay, and then next level is 46. 6. Means same level, next element is 46. So in this way that tree will represent. So this is the input for our program. Okay, whatever the elements are given, that we need to sort. Okay, and we can store that like this in the array. Okay, so now here is the first index, second, third, fourth, fifth and sixth, and here is the zeroth index. So now actually what we need to do, firstly we need to do apply Heapify method on this and find out the max heap. So if you apply Heapify method on this, we can find out the answer. Okay, so we need to reject all this element. Okay, we need to consider this elements only, which are the non-leaf nodes. Okay, so find out whether that parent node is greater than its children's. Yes, parent node is greater than its children's. So for this 91, no need to process anything. Now consider 15. So 15 is the 15 is greater than its children? No. So in that case we need to swap. Okay, so we will swap here. The tree will be like this: 77, 15, 91. Sorry, here is 21, we need to swap, and here is 15. 6 is as it is and 46 is as it is. Now again we need to process 77. Check whether his value is greater than his children's. We need to consider this subtree. So this value is greater than its parent. So we need to swap it. So we will do swapping here. So after swapping we will get 91 here and 77 here. And rest of the tree will be 7. Same 21, 15, 6 and 46. Okay, so in this way we can find out the heap here, find out the max heap. So this is the max heap. Okay, so how we can represent that max heap in the array. Okay, so let's see. First level 91, second level 21, 77, next level 15, then next 6, and then next one is 46. So in that way we can represent first, second, third, fourth, fifth, sixth index. So in that way we need to represent. Okay, so this is the Heapify method we have applied and uh, find out the heap max heap. Now what we need to do? We need to perform swapping on what? Root and last the node. So last node is 46 and root node is 91. Okay, so we need to swap it. So after swapping, what will happen? This 91 remaining nodes are same like this. Okay, you can copy remaining nodes are same, and this 46 and 91 means root and the last node will be swapped. Here also we can consider root node and the last node that we need to swap. Okay, so 46 will go here and 91 will come here. Okay, and that array size is reduced by 1. So I have reduced array size. This is another one array and this is another one array. Consider like this. Okay, so here what we have done, swapping we have done here. So this is the first step. Now in the next step, same thing we need to do. Again what we need to do? We need to swap and we need to apply Heapify method and find out the uh, max heap. Okay, so apply Heapify method on this. So what is this? This we can say as the tree like this: 46, 21, 77, then 15, then 6. The tree is like this. So if you apply Heapify method, on which node we need to apply it? Okay, so which node we need to consider? We need to consider only non-leaf nodes. Okay, so these three are the leaf node right now. So we will consider 21. So check, this is the subtree. This is the max heap or not? Yes, 21 is the maximum than 15 and 6. So we will not swap it. So let's take the new root element 46 So 46 is maximum than 21 and 77. Is it? No, it is not a maximum. So in that case, we need to swap. So which element we need to swap? Which is greater? 77 is greater. So we need to swap it. So 77 is here, 21 is here, and 46 will go down. So in that way, it will work. Now check whether it is maxi or not. Yes, this is maxi. This is also maxi. So how we can represent that into the array? We can represent that into the array like this. 77 first one, then 21, then 46, 15, 6, and here in the next uh, array there is the 91. So here we have applied Heapify method. So now next step is we need to swap it and reduce the size by 1. So which element we need to swap? Last element with the last element with the root element we need to swap. We can say first element in the array. Okay, so here 6 will go here and 77 will come here and 91 here as it is. Okay, we will reduce the size of an array like this and remaining will be same as it is. Okay, so this is the second step. Now in the third step, all elements not sorted yet. So what we will do in the third step, we need to again perform this two steps. First of all, we will perform Heapify and then we will swap. So apply Heapify method on this. Okay, so what is this tree in this next? 6, 21, 46. Here is the 15, here is the 77, and here is, so sorry, 77 is not there. So this is the tree. So apply Heapify method and find out the uh, tree. Okay, heap tree. So after applying Heapify methods, we need to apply only the non-leaf nodes. So 21 and 6 both are the non-leaf nodes. So find out whether it is a max heap or not. Yes, it is a max heap. 21 is greater than 15. So no need to perform any operations. Now consider this subtree. Okay, 6 is greater than its children's? No. So in that case, we need to swap. So which element we need to swap? Either 46 or 21. So we need to compare this two element and find out the maximum element, and that we need to swap. So 46 is maximum, so we will swap this 46. 6 will come here. Here is the 21 and here is the 15. So check whether it is a max heap or not. Yes, this is the max heap and this is also max heap. Okay, so we can store after applying Heapify method, we'll get this tree like this: 46, 21, 6 and 15. Here we have apply Heapify method. Now next step we need to apply swap. Okay, swap process. Okay, so after applying swap process, this size will be reduced by 1. So here 77 as it is, 91 as it is, 21, 6 as it is. Just we need to swap this last element, that is 15, with the 46. Okay, so 46 will go here and 15 will go here. So in this way we can swap. This is the third step. Now again 3 elements are remaining in the heap. Okay, that is 15, 20 and 6. So how we can represent it? 15 is the root element, 21 is the left of it, and 6 is the right of it. Now check whether it is a heap, max heap or not. It is not a max heap because parent value is not greater than its children's. Now we need to apply Heapify method, and a Heapify method should be apply only the non-leaf node. So 15 is the non-leaf node. We will apply Heapify method only on 15. So after applying this, we will swap it. So after swapping, we'll get here 21, 15 and 6. Okay, so this is the max heap right now. So after applying the Heapify method, your array will be like this. How many elements? 3, 21, 15 and 6. And here another array, 46, 77, 91. Okay, so which element we need to swap? we need to swap first with the last one. That is the next step. Okay, so and array size will be reduced. So array size will be 2 right now. Heap array size we can say. So here is the 40, here is the uh, 46 as it is, 77 as it is, 91 as it is, 15 as it is, and this 21 and 6 we need to swap. So 20 will go, 1 will go here and 6 will come here. Okay, so in this way we need to perform. So this is step number 4. Now in the next step, what we will do, only two elements remaining in the heap, 6 and 15. So heap will be like this, 6 is the root element, 15 is the left element. Now apply heapify on it. Okay, so if you apply heapify, so it will be applied only on a non-leaf nodes. So non-leaf node is 6. Find out its subtree, whether it is a max heap or not. So it is not a max heap. So in that case, to do it max heap, we need to swap it. So after swapping, 15 will go up and 16 will go down. Okay, so how we can represent it after if applying heapify? So element will be represented as a 15, 6, and another array is 21, 46, 77, 91. Now we need to perform swap operation after heapify. And which we need to swap? Last element we need to swap with the first one. So last element is this one, first element is this one. So we need to swap it. So after swapping, size will be reduced by 1. So this 21 will be as it is, 46 as it is, 77 as it is, 91 as it is. Just we need to swap this one. So 6 will be there and 15 will be there. Now all elements are sorted. Only one element is remaining in the heap. That element is the 6, and always one element in the max heap. So this is the last step, and here we'll get the sorting of all this array, 6, 15, 21, 46, 77, and last one is the 91. So this is sorted element. Okay, so in this way we can use heap sort. Okay, or we can use heapify method, swapping in the heap sort. Okay, so this is regarding the theoretical part. Now we will move towards the practical implementation of it. So here is your program. We need to implement it in C++. Okay, so what we need to do, we will see first of all which functions we require. So we require heapify function. Here is the procedure for heapify function is written, that we will see later on. And after that I have written heap sort function, okay, which will be required to sort the element. Means this array we will maintain into the heap sort. The next one is the build max heap. This function we have maintained to call heapify method for each and every node in the tree. And here is the main function. Okay, so we'll see first of all what are the inputs for this particular program. So input is number of elements that we need to sort. Suppose that is n. N is the number of elements that we need to sort. So we need to increment n because we need to store numbers from 1 to 6, 1 to 7, whatever it is. 0 should be blank. 0th index should be blank. That's why we have done here. And always we are starting from 1 to less than n. Suppose if you are considering this example, okay, suppose 77, 15, 91, 21, 6, and here is 46. If you are considering this example, how many elements are there? 6 elements are there. But here we are considering 1 to here we have incremented 1 n by 1, so there is 7. So we will go from 1 to 6. That's why it is written. So every time we will accept the new element and that we are storing into the array. Okay, then we will build the max heap first of all. That is the first step of the heap sort that we have seen. Okay, In here we have seen what is the first step of the heap sort. We need to apply heapify method, and then we need to swap and reduce the size of an array. Okay, so here you can see here, so build max heap that we have called to create apply the heapify method, and then sort function we have called for sorting it before swapping that elements, and then we have displayed that element. That's it in the main function, nothing else. Okay, so we will see first of all the max heap function and heap sort, how it will consider here. Okay, so in the max heap function, first of all what we need to do, we need to avoid all the non-leaf nodes. And how we can find out the non-leaf nodes in the array? By using n by 2 we will find out the non-leaf node. If you are storing particular numbers in the array, okay, so for example here is 77, 15, 91, then 21, 6 and 46. This is the max heap. So if you are storing that numbers into the array, okay, zeroth index will be black. How we can store? First index 77, then 15, then 91, then 21, then 6 and then 46. So this is the index of an array, we can see. Okay, 4, 5, 6. So in this way we need to store. So practically how we can find out the left child and right child of a node and a parent of a node, because we need to compare that. Okay, so if you are considering if ith node, okay, means for node at I location, okay, the left child for that node is 2I, okay, and right child for that will be 2I plus 1. And parent node, if you are considering, then parent node is I by 2 location. Let's see the one example. Suppose I is 2, means at the second location whatever the node is there, for that we need to find out the left child and right child and the parent node. So we can apply this formula for that. Okay, so this for this 15 we need to find out the left child. How we can find out left child? We can find out by using 2I. 2 into I, value of I is 2, that is 4. So at the fourth location left child is there. So see, left child of 15 is at the fourth location. Now right child is at the 2I plus 1 location. We already calculate the value of 2I, that is 4. So 4 plus 1 means fifth. So at the fifth location right child of 15 is there. Yes, left child of 15 is 21 and it is at fourth location. Right child of 51 is 6, which is at fifth location. And parent node, how we can calculate? I by 2. So I value is 2 and divided by 2, that is 1. So parent node is at the first location. Means index of the parent node is 1. Means by using this formula we will find out the index of its left child, right child and the parent node, because we need to compare that elements in the heapify methods. Okay, that's why we need to use this formulas. Okay, so let's see this heapify method. We are passing array where we are storing the elements, then we are passing I, for which we are using this heapify, uh, for which uh, element we are calling this heapify method, and then n means number of elements. Okay, so here temporary we have taken temporary variable we have taken, where we are storing which element we need to process. So suppose first we need to process this element 91, okay, which is at the third location. Okay, so 91 will be stored into the temp that we need to process. So this is the variable which we have taken for storing the processing node. Okay, so in the temporary variable we are storing node, that is 91 in our example. So how we can find out the left child of it? We can find out by using 2I. So 2 into I. So if you are considering 90, this one, so I value will be 3. Okay, index value will be 3. So 2 into 3. So 2 3s are 6. So j will be 6, means its left child will be stored at the 6th location. Okay, so we have seen left child is at 6th location. Okay, so in this way we can find out the left child. So now in the while we have written condition j is less than equal to n or not. Why we require this condition? N is the number of elements and j is its left child, means either left child is not there or not, or right child is there or not. For that purpose we have written this condition. If j is less than n, then there is the right child or left child. That's why we have written. Then we have check here, a j plus 1 is greater than a j, means what we are doing, j is our left child, okay, and j plus 1 is our right child. Okay, so we will compare its left child with the right child. Okay, and if left child is greater, we will consider that, if a right child is greater, we will consider that right child as a j, and we need to swap this right child. And if right child is not greater, then in that case we will check whether a temp is greater than a of j or not. Okay, means whatever the jth element is there, means left element is 46 is there, is this 46 is greater than 46 is sorry 91 is greater than 46 or not. If it is greater, then we need to break. We don't have to do anything because it is max shape. Okay, this is max shape, so no need to do anything. Okay, it will not execute anything, it will go outside, and a of j divided by 2 is equal to 10. टेम्प में कौन सा नोट स्टोर है 91. So we need to store that at the j by 2. So what is j? J is your this this fifth location, sixth location. Okay, where we need to swap this with it. Okay, so likewise we need to perform. Then here, if the value of right child is less, okay, so temp is less than equal to a of j. A of j means if the value is greater, left child value is greater, in that case we need to do swapping. So we will swap that with the a of j by 2. So j by 2 means here with this we need to swap it. Okay, so after swapping with j will be 2 into j. Okay, so in this way we will compare the element and store that element into the array. Okay, means here what we are doing, we are finding out the max heap. Okay, we are applying the max heapify method. Now here we will perform the sorting. So in the sorting function we will pass array and n number of elements. So I equal to n, I is less than greater than equal to 2, I minus minus. So from n we need to start. Okay, because from last element we need to consider order. Okay, and here I equal to n, I is greater than equal to 2, and I plus I minus minus. So sorting maximum value at the end. Okay, so a of j we will store into the term. Here we are doing swapping actually. Okay, means actually we are doing sorting here and building max heap of remaining element. Okay, so we will call, this is for only one element. So another element we will call max heap, we will call for another element by here. Okay, so we will pass a1 and I minus 1, means next element. For the next element we will call again heapify method, and again heap sort again first. For the next element we will call, likewise we will process this heap sort and heapify for each and every non-leaf node. So in this way this heap function will work. Okay, so now what will the output of this particular program? So if you enter the number of elements and element as a 5, and these are the element, it will just display the sorted elements 2 3 6 11 12. So in this way we can perform the heap sorts. So let's summarize this particular session. Okay, previously we have seen this what is a heap. It having two properties, it must be the almost complete binary tree, mean heap or a max heap. Mean heap means the parent value is less than child value. Max heap, parent value is greater than its child value. So heap how we can represent by using array from index 1 to number of elements. Okay, we need to consider, and we can find out the left child by using 2i, right child by using 2i plus 1, parent node by using I divided by 2. Okay, this is the array representation, and how we can find out the left and right child and parent node in the array. Now to construction of a tree, sort, two methods are there: heapify and insert key one by one. In the heap sort, we are using heapify method. So in the heap sort, two steps are there. First, we need to perform this two step up to all elements are sorted. First is the heapify method. We need to apply and create a max heap. Okay, and then swap root with the last and reduce the size by 1. This actually we are performing deletion process. So this is the example of it. Here is the representation of it. How we can represent level by level from left to right. In that way we can represent. Then we need to apply heapify method. So we have applied heapify method and created array. Okay, then we need to perform swapping. So tree will be like this. Okay, same way we need to apply heapify, swap, and up to all elements are swap. Okay, up to all elements are swap. So this is your sorted array. So in this way we need to perform the heap sort. So thank you all of you for patient listening. Take care. Have a nice day ahead.